Oh!
The phone is a blue iPhone 13 Pro Max. There's a wave antenna on the middle frame, which indicates that it's indeed a US version from the outside. This phone doesn't have any signs of serious drops or collisions. Since it doesn't display, let's plug in the charger for a look. We find that there is charging current, but the screen is black, so there's no display. We can see that fast charging is activated, yet the screen is still not displaying anything. Why would it suddenly stop? Displaying while being used normally? Those who are still watching at this point must be big fans. Don't forget to double tap the screen to like and follow. Thanks for your support. After watching this video, everyone is welcome to discuss the question. Is it a quality issue or a user issue? Also, we hope you can learn more through this video. Let's heat up the screen, then remove it. After taking the screen off, we first observe, although this is a US version locked device, luckily, it's the first time it's ever been opened. The inside is very clean and organized. We first protect the front Face ID components and camera, unscrew the retaining plate, and first disconnect the battery cable. Next, remove the display/touch connector, and finally disconnect the sensor cable, so we can remove the screen. Since the phone only doesn't display, and it can power on, our first step is to rule out a screen issue, so we bring out a test screen, attach it to power on and test, using the test screen. We plug in the charger. We find it's still the same issue, there's charging current, but the screen has no display. This means the no display problem isn't caused by the screen, but by the motherboard. Next, we need to remove the motherboard to find the fault. You definitely wouldn't guess what the problem is. If you want to learn more, make sure to keep watching until the end, because this phone is a US version. It has a wave antenna, so the motherboard can't simply be taken out from here. We need to remove the Taptic engine, speaker, and battery first, then remove the wave antenna. That's the only difference from the Chinese version. It has a wave antenna. Some people quietly watch the video, but they secretly like, comment, share, repost, and follow. People like that are just too cute. Pull out the battery adhesive to remove the battery. After taking out the battery, you can see the wave antenna on the side. Unscrew these 3 screws, remove the retaining plate. Disconnect the wave antenna, and we can remove the motherboard. Taking out the motherboard, let's observe this board. Since it's a stacked logic board, we need to check if there are any cracks or signs of bending. We've ruled out the screen for the no display problem, so now let's measure the current. Using a multimeter, we measure each point. Take a clear look at these values. After testing, we find an abnormal area. The resistance at this corner should be OL, infinite, but our actual measurement is around 200 ohms. That leads to a capacitor/resistor that goes to the display IC, so the problem lies in this route. Because the display IC is located within the stacked portion of the motherboard, we need to separate the board layers, remove the foam on the connector seat, put the board on a heating platform, and heat until the solder melts, which allows us to separate the upper and lower layers. Usually, on a Chinese version phone, many people wonder why a certain chip area is empty. Look here at the US version, it's populated with the wave related parts. The lower layer also has Wi-Fi and the baseband, etc. The upper layer has the CPU, flash memory, power, charging, display, audio, etc. First, let's measure the capacitor's resistance near the display connector, 0.257 ohms. Clearly, it should be OL. But we have a reading. We bring out a scrap board for testing. A normal board reads OL on one side and ground on the other side. We've encountered this type of situation quite often, so you could call it a common issue. This fault could be caused by the capacitor or the display IC. We use the process of elimination. First, remove this capacitor. If the value returns to normal, the capacitor is faulty. If not, the display IC is faulty. Okay, after removing the capacitor, we measure again. One side is OL, the other side is ground. So that means it's the capacitor that failed. This no display issue was caused by this faulty capacitor. Because it wasn't shorting both sides to ground, it's not easy to detect, so you need experience. We've fixed this kind of fault many times. Is it a quality issue or a usage issue? This capacitor must be replaced with one that's high voltage rated. After replacing it, we measure again. One side is ground, the other side is OL, so it's back to normal. We remove the protective stickers all around, clean the motherboard thoroughly, apply flux to the solder joints between the upper and lower layers, reflow each solder ball, then remove the excess solder using solder braid. Wiping everything clean, we do the same for the lower layer to make the connecting points neat and clean. After that, we place the lower layer on the reballing fixture, apply solder paste to the points, wipe away the excess, and heat until each point melts. Some people quietly watch the video, but secretly like, comment, share, repost, and follow. People like that are just too cute. After that, we put the lower layer on the heating platform, apply flux, then apply thermal paste to the CPU on the upper layer, and align both layers. Once the solder fuses, we gently touch the upper layer to check for a bouncy QQ feel, and then quickly cool the motherboard. After soldering, we remove and replace all protective stickers with new ones, clear out the dirt near the SIM card slot, and the motherboard's cosmetic work is done, we take out a pink housing, clean out the dust, install the motherboard, reconnect the wave antenna, screw in the antenna bracket, then reinstall the Taptic engine and the speaker. We apply new adhesive for the battery, place the battery back in, and use a roller to secure the battery more firmly. Now we handle the old adhesive around the housing, tighten the motherboard screws, and apply a new seal, clean the edges of the screen, reinstall the screen, and, for the final step, connect the battery. Then clean out any remaining dust, remove the protective film on the waterproof adhesive, remove the cover from the Face ID module, and close the screen. Place the phone in a press tool to ensure a good seal. Some people quietly watch the video, but secretly like, comment, share, repost, and follow. People like that are just too cute. After pressing, we remove the phone, insert the 2 screws at the bottom, and use a special cable that shows charging wattage to power on the phone. Okay, success. The screen lights up with the Apple logo because the owner previously reinstalled the system while preserving data. We are at the activation screen. Also, when the phone wasn't displaying, it might have triggered voiceover for the visually impaired, causing it to tilt up. Some people quietly watch the video, but secretly like, comment, share, repost, and follow. People like that are just too cute. Step by step, we activate the phone. Let's first check the Wi-Fi function, since the lower layer has Wi-Fi in the baseband. If these two are normal, the lower layer is fine. About this phone, it's a 128GB US version iPhone 13 Pro Max. The carrier info here shows the SIM card is locked, so it's a locked phone. We don't have a SIM unlocking sticker on hand, so let's test with *#06#. The IMEI pops up, meaning the baseband is working. Then we test other functions. We dial 1212, and it can dial out without the unlocking sticker. If we insert a SIM card, it will prompt for reactivation and then show a SIM error. Based on these tests, the baseband is normal. So, do you think this is a common problem or a quality issue? Feel free to discuss in the comments section. Thank you all for your support.